One thing that's important to note, as we're solving a system by the addition method, the system needs to have the x and the y's all on one side. So in order to solve this particular, or to start to solve this system, the first thing I would do is put all the x's and y's on one side of the equation. So the first one, I'm going to subtract 7y from both sides. And on the second one, I'm going to subtract or add 3x to both sides. So now I have a system that, at least in its form, I can start to begin to think about adding them. However, it does appear though that I can't think of any number to multiply to either the top line or the bottom line such that the variable will disappear. So what I will do then is maybe I can multiply something to the top and to the bottom. So let's multiply the top one by a 3 and multiply the bottom one by a -2. Are you seeing why? Well, let's look and find out. 3 times a 6x, or 2x, 3 times a -21y, 3 times a -17 is a -51. On the second one, -2 multiplied in gives me a -6x, minus a 10y equals a -34. And there you can see what I did is that I multiplied by clever numbers here, 3 and -2, so now that my x's are going to be eliminated. So now I will have is a -31y equals a yikes, what is that, 17? -17. Now I'm adding them, so that's going to give me a -85. And then y equals 85 over 31. And that's very possible that I might have a messy fraction that pops out. I'll just take that number, plug it back in, and work through it. Not every problem you're going to work is always going to have nice, clean solutions. Some of them may have, some fractions involved, but you can still deal with them nonetheless.